So we're going to do arc length. This is the formula for arc length when the angle is in radians. So that is something that you would want to write down. If you forget from geometry, arc length, let me see. Nope. Okay, so arc length is this out here. So it's just like the length of this crust. So it's just this piece right here where it says S. I think we went over some of this yesterday, but obviously R is radius. This symbol here stands for theta. It's the central angle, which is this angle right here that is formed at the center of the circle. So S equals radius times central. That's on the next one. So this first example says, in a circle with radius 10 centimeters, an arc is intercepted by a central angle with measure 7 pi over 4. Find the arc length. So you are just plugging in. So this would be our radius. Oops. Radius. This would be our theta. So S equals 10 times 7 pi over 4. You can just write this as a fraction, multiply straight across the numerators. So 10 times 7 is 70, and there's also a pi there. 1 times 4 is 4. That could be written as 35 pi over 2. If you wanted to get an estimate, you could type the pi part into the calculator. So it's about 50, we're actually just going to call it 55. So it's about 55 centimeters. And this next one, I just want you to try. So take a couple seconds, try to do this one, make sure you know what you're doing. You can, okay, so this one, you would so 15 is your radius. Wow, guys, I can't type. Okay, anyway, 15 is the radius. Theta is pi over 3. You're multiplying those together. You can rewrite 15 as a fraction. You have 15 times pi, so 15 pi. 1 times 3 is 3. Some people told me it was 5 pi. Totally fine. Other people told me it was 15.7. Also totally fine. Okay, so arc length formula, this time angles in degrees. This formula is the exact same. The only difference is that it adds this piece right here on the end, which if you remember from Monday, that's how you convert from degrees to radians. So it's just including the conversion in the formula. All right, so this is a problem where the angle is in degrees. So it says Santa is in an approximate circular orbit 400 kilometers above the surface of the Earth. His elves track the sleigh when it's 45 degrees central angle of the circular orbit above the tracking antenna. How many kilometers does he cover while he is being tracked by elves? Assume the radius of the Earth is 6,400 kilometers, round to the nearest kilometers. So, a lot of information. First thing, we can kind of just look at our variables. So, we have this 45-degree angle, so that is going to go right here for theta. The radius on this one is sort of weird. So, the radius itself is 6,400. But if you look at the picture, it's not just the radius, but he's also this additional 400 away. So your total radius in this problem, you would need to add 400 to that because he's actually 6,800 kilometers away. So this time, this would be our R. And then you just plug everything in just like last time. So I have the radius, which we said is the 6,800. our angle, which is 45 degrees. This pi over 180 will convert it to radians for us. And you're more than welcome to just type that entire thing into a calculator just like I wrote it. When you type it in, you would get 5,340.7.